Hi friends, in this video let's discuss the shortcut for the divisibility rule for 11, 7 and 13. We have already covered in the previous video the check for 3 and 9, so I'm crossing those over, and let me highlight the ones that we are focusing over here, 7, 11 and 13. Now let's start with 11. If you have any number, say 5, 7, 9, 3, 2, suppose this is the number which you want to check whether it is divisible by 11. All you need to do is, so for the rightmost part you give a plus, then a minus, plus, minus, plus. So what is it that you have to do? You have to find the sum of the digits at the odd places. 2 plus 9 plus 5, which is 16, and you have to find the sum of the digits at the even places, which is 7 plus 3, which is 10, and find the difference, because all these, you see, these are plus, so you're getting plus 16, and then you're getting minus 16, minus 10, sorry, here, and you add it, you get 6. So if this number has to be divisible by 11, then whatever you get over here has to be divisible by 11. But because 6 is not divisible by 11, because the remainder is not equal to 0, therefore this number is also not divisible by 11. So that's the answer for the question, is it divisible or not, and the remainder that you get would be the same that you're getting over here. So if you divide this number by 11, you will get a remainder of 6. Now the rule for 7 and 13 is the same. If you want to check the divisibility, let's take a number, say 1, 2, 4, 5, 9, 6, 7, 8. So you split it into groups of 3 from the right. You give a plus to the first group, a minus to the second group, and then the plus to the third group, and it goes on like that. So you add all the pluses together. So 678 plus 12 is 690, and then you subtract the minuses from it. 459, you have to subtract 459 from it. You are left with 1 and 3, 2, 231. So you have, so if this number has to be divisible by 7 or 13, 231 has to be divisible by 7 or 13. Now is 231 divisible by 7? That's something that you can do in your mind. 231 by 7, you have the first two digits, so 23, that goes 3 times. You are left with a remainder of 2, and then 21, which also goes 3 times. So 231 is divisible by 7. So this number is divisible by 7. Yes, divisible by 7. Now is 231 divisible by 13? Again you have 23, it goes 1 time. You are left with a remainder of 10, and then you have the 1 coming down, so it's 101, which is not divisible by 13. 13 into 7 is 91. You have a remainder of 10. So this number is not divisible by 13. Therefore this number is not divisible by 13. Quick recap. So for 11, all you need to do is you need to find the sum of the digits at the odd places minus the sum of the digits at the even places. And for 7 and 13, you need to divide the numbers into triplets, and then from the rightmost part you give a plus, a minus, and a plus, and it goes on like that. You find the sum, and then you check whether the number that you're getting is divisible by 7 or 13 respectively. So let me cross off 7, 11 and 13, and let's have a quick example for what we just learned. Okay, so we have this number over here. Let n be a very big number, 321, 321, and it goes up to 300 digits. Now you want to check whether this number is divisible by 11, 7 and 13. So you know that, let's start with 7 and 13. You know that the rule for 7 and 13 is you divide it into triplets. So you see that this is a pattern where 321, 321 is being repeated. So every triplet would be 321, right? So the rightmost triplet also would be 321, which would get a plus, and then the next triplet would get a minus, then the next triplet would get a plus, and it keeps on going. So how many triplets will be there like this? Every triplet has 3 digits, and you have a total of 300 digits. So you have 300 by 3, which is 100 triplets, and out of these 100 triplets, 50 will have a plus sign and 50 will have a minus sign, right? See, the first one would have a plus. If you have just 2 triplets, it would be a plus and a minus. Similarly, if you have 100 triplets, there would be 50 plus and 50 minus. So it all adds up to 0. Now, because 0 is 0 by 7, you get a remainder of 0. Therefore, this number is divisible by 7. So you're getting yes over here, and because the rule is the same for 7 and 13, 0 by 13 is also, you get a remainder of 0. So this number is divisible by 13 also. Now we are left with checking the divisibility for 11. So for 11, we saw that all you need to do is you need to divide the number, like if your number is A, B, C, D, you need to give a plus over here, a minus over here, a plus over here, a minus over here, and add and find the answer, right? And then check whether that number is divisible by 11 or not. But in this case, there's one more modification that you need to keep in mind. So for 11, you can either take, so suppose if your number is A, B, C, D, E, F, G, H, suppose it's a big number, so you can either take, as we discussed, one digit at a time and give a plus, a minus, a plus, and it goes on like that, or you can take 3 digits at a time and do the same thing. So for 11, you can take odd number of digits at a time. So that's an additional point. You can take odd number of digits at a time. So the usual case is you take one digit at a time and you give plus from the right and you keep doing that. But in this case, it's much easier if you take triplets at a time. So again, there would be 100 triplets, and the rightmost would have a plus and the next one would have a minus, and it keeps on going like that. Therefore, here also the sum would be 0 and this number is divisible by 11.